All right, we're going to start working on our second lesson with exponent rules. So we're going to be going through a couple of facts, exponent rules, and kind of just stating, trying to figure out why they're true mathematically, and then practicing with those rules. So the rule that I have stated up here says that a to the 0 power equals 1. That means literally anything here raised to the 0 power will always equal 1. So that is a fact or a rule, and the question is, why is that the case? So I'm going to ask you to simplify the expression down below, and we're going to simplify this expression using the product rule. So product rule states that you would take, if there's multiplication, you would take your powers and add them together, and that would give you n plus 0, which is just n. Okay, so what actually happened here, if we skip this middle step and we look at the problem from here to the end, it appears that a to the 0 did nothing in terms of changing the answer, which means that a to the 0 is really like multiplying by 1. Okay, so that's the algebraic reasoning as to why a to the 0 is the same as just multiplying by 1 whole. Here's what some examples could look like containing 0 exponents. So all these examples have 0 exponents, but they're located in different places, and the placement of that exponent will determine what your answer is going to be. So for example, this first one, 4 to the 0 power, that would just be equal to 1 whole, because anything to the power of 0 is 1. Something like b, however, with this addition of the negative in the front, this negative is technically serving as a coefficient of -1. So when you read this, what you need to read it as is -1 times x to the 0 power. And then to solve, you can do x to the 0 power first and say, okay, well, we just learned that that's equal to 1, and then multiply by your coefficient, and so you're getting an answer of -1 for that example. In example C, you have 4 and x both being raised to the 0 power. So if work was shown, what we would want to do is we would want to do the power rule, meaning take your powers and multiply them. So this would become 4 to the 0 and x to the 0, and that means that each one of those terms is like equal to 1 whole, and so your answer would be 1 again. Okay, a couple more. What about example D? So example D, -12 is being raised to the 0 power. That means that that is equal to 1 because this whole number is being raised to the power. With E though, see how there's no parentheses on this one? So what's happening with E is we kind of need to look at this as two separate components, the 4 and then x to the power of 0, and then analyze. So x to the 0 power equals 1, but I still have this 4 that I would need to multiply by to get my solution. Okay, last one. I'm going to break this apart also. So this would actually be the same as 0 times x to the first times y to the 0. So this 0 power is only attached to the y because there are no parentheses attaching it to anything else. And then if you solve, x to the first power is the same as just x. Y to the 0 is the same as 1. So we're doing 0 times x times 1. Well, 0 times anything is equal to 0. So 0 is your answer there. All right, factoid number 2. This one usually is a little bit tricky. The fact up here says that x to a negative power is equal to 1 over x to that power. So let's look at this a little further. Why would this be? Well, if I use product rule, and product rule says that I would add my exponents. So that would turn this into x to the n plus negative n power, and simplify, m plus negative n is 0, And as we just learned, x to the 0 power is equal to 1. So if we wanted to skip out these middle steps, what just happened? What does that mean about this x to the negative n power? Well, the only way that you can multiply by something and get an answer of 1 is if this thing was equal to 1, or if you multiplied by a reciprocal. So reciprocal for x to the n would be 1 over x to the n. And if you multiply something by a reciprocal, you end up getting just 1 whole. And so that's just giving us a connection piece, guys, to the reasoning behind why x to the negative power is really equal to a fraction. All right, so these are a little tricky, okay? So bear with me, watch closely with this section. 10 to the power of negative 2. If your job is to simplify, that means that you're going to turn this into a positive exponent. So this negative power here means that it needs to be rewritten as a fraction, okay? And then once you rewrite it as a fraction, the exponent can change from negative to positive. So 10 to the negative second is equal to 1 over 10 to the second. And then this time, just because I have numbers, I can simplify and say 10 to the second is equal to 100. So 1 over 100 is your solution there. In example B, same thing. When you see a negative exponent, what you need to do first is turn that into a fraction. Now be careful. The negative exponent is only attached to the c. So the c squared, is the only thing that will go into the bottom of your fraction. Anything else will stay on the top. So the negative 3 will remain on top, and then c squared would go in the denominator. Okay, 2 more of these. We have a couple of negative exponents happening in example C. We also have a 0 exponent. So I think maybe I'm going to take that 0 exponent and rewrite it as a 1. And you're multiplying it by other stuff. So multiplying by 1 is not going to change your answer, is it? So if you wanted, you could just maybe take it out. Next, I'm going to go to each negative exponent separately, and I'm going to make it into its own fraction. So 2 to the negative 1 power is the same as 1 over 2 to the first power, or you could just say 1 over 2, times 1. And then b to the negative third, that would be 1 over b to the third. Now I'm going to multiply all this stuff together. Remember, top times top, bottom times bottom, that's how that works. So the bottom would be 2 to the first, which is just 2, times b to the third. So the bottom is going to be 2b to the third. Okay, last one. So this time we have a negative exponent, and that negative exponent is on the outside of a parentheses, right? So the first thing we're going to want to do is do the power rule. So multiply your exponents. So 3 to the negative 2, x to the negative 2. Now you have negative powers attached to each term. So you're going to rewrite each one of those as a fraction, like so. And then you're going to simplify 2 things. I'm going to do top times top, bottom times bottom. But the bottom, I'm also going to do 3 squared and make that 9. Okay. Let's look at some more challenging problems now. So just a quick note. If someone tells you to simplify something in math regarding exponent rules, that means you do not want any 0 exponents in your answer, and you do not want any negative exponents in your answer. No 0 exponents, no negative exponents. Okay, here's your first simplify example. So I'm going to actually show you 2 ways to do this problem, and you can do this problem either way. Whatever you think makes the most sense to you, that's what you're going to do. Okay, so option 1 is you're going to see that there are negative exponents for each, and you're going to turn each of these things into a fraction. Okay, this is method number 1. And then from here, you're going to take each fraction and simplify the number on the bottom. So this would be 100, and then the right side is 1,000. And then multiply your answers together. So you would have 1 over 100,000. Okay, that's option 1. Let me show you option 2. So option 2, what you could do from the beginning is you could do product rule. Because this is a multiplication problem, right? So you can do product rule. And product rule says to add the exponents. So this would be equal to 10 to the negative 5th power. Now you could take 10 to the negative 5th power and write it as a fraction, 1 over 10 to the 5th. And then you could use a calculator to simplify 10 to the 5th, which is 100,000. So you get the same answer either way. Okay, I don't care which way you use because both are correct. Next example, same thing. I have 2 different options for you, and you can choose whatever you like better. So the first thing I'm going to do is power rule. So power rule is going to multiply my exponents. So I'm going to get negative 3 to the negative 2nd power, and then 5. Now watch, when you multiply the exponents here, you actually end up with positive 2. Okay, take your negative exponent, which is just this one, and turn that part of the problem into a fraction. And then simplify. So you have 1 over negative 3 squared is 1 over 9. 5 squared is 25. So your solution ends up being 25 over 9. Remember, when you multiply by fractions, top times top, top times top, bottom times bottom. Okay. Option number 2. You're going to use the negative, or simplify the negative exponents first. So option number 2, you would say negative 3 times 5 to the negative 1st power, all raised to the power of negative 2. I'm going to simplify inside the parentheses first this time, meaning I'm going to change that 5 to the negative 1st power into 1/5. And then we could multiply 3 times 1/5, and we get negative 3/5. Now watch this closely. We'll see more like this here soon, but watch closely. Now, if I want to apply the negative exponent, what's going to happen is, since I already have a fraction, the negative exponent is going to make the fraction flip. And once the fraction is flipped, the exponent is no longer negative. So that negative is like an action, okay? The negative flips these numbers upside down, and once they're flipped, that negative goes away. Then to finish up the problem, you're going to take negative, let me go back. You're going to take negative 5/3 and you're going to square it. So basically you would just square the top number and square the bottom number. So this would become 25 over 9. Same thing, you got the other way. Okay. I think this is one of our last ones. So this one's got a lot happening. I would say maybe let's find any 0 exponents and make those just be a 1. So my coefficient is actually just a 1 here. All right, now your negative exponents, as you know, if I had x to the negative 3rd, as you know, that's equal to 1 over x to the 3rd. But the story is a little different when you already have a fraction in your problem. So what you will be doing is you will be taking anything that's a negative exponent and moving it to the other side of the problem. And that's because you can't make it into a fraction if it's already 1. So all you can do is kind of flip it around and move it to the other side. So anything with a negative exponent is going to go from either the top to the bottom or the bottom to the top. So let me write down what I would have. On the top, I have a 1 and a y, and then these two things are negative exponents, so that means they're going to move to the top. Remember, when they move, whenever something moves around, the negative exponent goes away. And then the bottom is going to end up with a 2 that's already there, and then an x to the third that is coming down. All right, guys, from here, you're just going to simplify. So like, see the y's on top? Those are product rule because they're multiplying. So you can add those exponents and get y to the third. The 2 on bottom doesn't have anything to combine with, so just leave it be. And then your x's, you can subtract your exponents. 3 take away 1 would give you x squared, x to the second. And I did put those on the bottom of my answer because that's where there were more x's to begin with. So any of your leftovers will also go on the bottom. Okay, so there's option 1 for how to do this problem. Let me write it again, and I'm going to show you another way that may be easier. Okay, so your second option for how to simplify, you are still going to make the 0 power portion equal to 1. But maybe what you want to do this time is do the quotient rule. So that means take your coefficients and divide them, which makes them 1/2, and subtract your exponents. So I'm going to write it out like this. It would be -3 minus -1 for the x's, and then y's would be 1 minus the bottom exponent, which is -2, and then simplify. So you have 1/2 x, this would be a plus, so this would be x to the negative second, and then over here would become a plus. That's going to make it y to the third. And then remember, anything that has a negative power is equal to 1 over that amount. So this would be 1 over x squared. And then top times top, bottom times bottom to finish this up. Okay, again, either technique works. Both give you the same result, so you can choose whichever way you like better. All right, so here's a list. I just made this little summary sheet for you, so you didn't have to flip back and forth between all of your notes papers. This is just a little formula sheet telling you all the different rules: product rule, quotient rule, power rule, and then the 2 from today. Okay, so that should be enough information for now to get started on your Delta Math assignment. No, I'm sorry, not Delta Math. This one's a worksheet. To get started on your worksheet. If you have any trouble and you just want some clarification, please don't hesitate to email me and I'll get right back to you.